So, this video is day 1, part 1, and so we're going to go through 4 things right now. We're going to go through operations with fractions, evaluating expressions, solving linear equations, and slope and writing linear equations. So, day 1 is a review of things you've gone over in Algebra 1. So, let's start with operations with fractions. And so, what you should be doing while you watch these videos is taking notes. Okay, taking notes, put whatever is on the board into your notebook, as well as if you have questions with the videos, remember, take a little side note of what questions you have, so that way when we're together in live instruction, you ask those questions. So, operations with fractions, okay, we have adding and subtracting, in which you cannot add and subtract fractions unless you have a common denominator. So you need a common denominator in order to add or subtract. So let's say number 1, 2/3 plus 5/7. Okay. Common denominator. Okay, there's a quick way to figure this out. If you take the denominators and multiply them together, okay, that's going to give you a multiple of both of them, which is going to be a common denominator. So we could say that 21. So what we're going to do is we're going to not change the value of each fraction, but just make them look different, create equivalent fractions by multiplying by a clever form of 1. So we're going to rewrite 2/3 to have a denominator of 21. That's going to be our common denominator. Times 7 times 7. So it's like you took 2/3 and multiplied it by 7/7. That's the clever form of 1. So 2 times 7, 14. Okay, so notice, when you make a fraction look different, okay, you're not changing its value, you're creating an equivalent fraction. 5/7 needs to become something over 21. You took 5/7 and multiplied it by 3/3 to get a denominator of that 21 there, right? What you do to the denominator must do to the numerator here. So that's going to be 15. And now when you add, okay, denominator stays 21s, okay, and 14 plus 15 puts us at 29. And you check, can you simplify this fraction? You can simplify this fraction if there is a common factor between the numerator and the denominator. There are no common factors, so number 1 is 29/21. Number 2, we'll do 6/5 minus 1/10 plus 11 halves. So we have 3 fractions, okay? And so remember, order of operations, adding and subtracting have the same hierarchy. We go left to right. And so if we have 3 denominators, we have to make sure we have a common denominator between all 3. And so if we notice, we have 5, we have 10, we have 2. 5 is 5 times 2. So we can get the least common multiple here. Okay, the least common multiple is going to be 10. Okay, but if not, you could just do 5 times 10 times 2, and that will just be a multiple. Okay, but we can use a common denominator of 10 here. And so 6/5 needs to be rewritten as something over 10. Not changing its value, just making it look different, times it by 2, right? So that's going to be 12/10. And 1/10, that's not going to change. 11 halves times something is going to give us something over 10. Times it by 5, so 5/5, that's a clever form of 1 this time, 55. So we're going to do 12 minus 1, that's going to give us 11/10. Plus 55/10, and that gives us 66/10, and there's a common factor between the numerator and the denominator of 2, so that's going to give us 33 fifths. Okay, and so that's it for adding and subtracting fractions. You need to make sure you have a common denominator. You can use any multiple of all the denominators as a common denominator, or you can try and achieve the least common denominator, which would be the least common multiple between all denominators. So, next up, multiplying and dividing. Multiplying and dividing a little simpler than adding and subtracting because you do not need to have a common denominator. When you multiply fractions together, you multiply the numerators across, multiply the denominators across, then look, can you simplify that fraction? No. There's your answer. So if we do this, 2/3 times 9/4, okay, multiply it across, okay, 2 times 9, we know that's going to be 18, just want to show you something, 3 times 4, right, we would be doing 3 times 4, that's going to give us 12. When you have two fractions being multiplied together, notice, here we have it written as factors, but we could break this down further. 9 is 3 times 3. 4 is 2 times 2. When you have a product in the numerator and a product in the denominator, you simplify your fraction when you have common factors in the numerator and the denominator. We can get rid of a factor of 2. We can get rid of a factor of 3. So what are we really left with? 3 halves. What does 18 over 12 simplify down to? 3 halves. So you could do it back at this step. 2 over 4 is going to become 1 over 2. 9 over 3 is going to become 3 over 1. And we get 3 halves. So next up is dividing. So if you have 2/3 divided by 5/7. So think about it like this, okay? 10 divided by 2, okay, is saying the same as 10 times 1/2. Okay, saying you're going to take 10 and split it, divide it by 2, okay, means what is half of 10? Okay, that of is multiplication. So when you have division, okay, what you do is you multiply it by the reciprocal of the second fraction. So 2/3 times 7/5 is the same as 2/3 divided by 5/7. Okay, these two are the same thing. Okay, dividing by 2 is saying it's times 1/2. Okay, so then you just go right into multiplication. This is 14 over 15. Can't simplify that, and we're done. Okay, so make sure you feel comfortable with the operations with fractions, adding, subtracting, multiplying, and dividing. And so now let's move on to evaluating expressions. So, let's make sure we do this without the use of a calculator. We're just trying to work on our number sense, working with numbers without using a calculator, working with our fractions. So let's remember, when we have an expression, we need to make sure when we are simplifying and evaluating that we are following our order of operations. Okay, PEMDAS. Okay, we always work inside our parentheses first, then we take care of exponents. Remember, multiplication and division have the same hierarchy. You work left to right with multiplication and division, and then addition and subtraction, they have the same hierarchy. You work left to right. So we're going to evaluate each expression. So number 1, let's do so 5 plus 5 times 5 minus, in parentheses, 4 times 3/5. So first thing we're going to want to do here is work inside our parentheses. So we have to do 4 times 3/5. Okay. So when you have an integer times a fraction, you can always make that integer a fraction by putting it over 1. So this is 4 times 1 over 3/5. Okay, that's going to be 12 over 5, and there's nothing left outside, so this is going to be now minus 12/5. This is 5 plus 5 times 5 minus 12/5. So now we have to look, okay, no parentheses, no exponents, so now we look, okay, left to right multiplication, right here, 5 times 5, that's going to be 25, so this is 5 plus 25 minus 12/5. Okay, so left to right, that's going to be 30 minus 12/5. And now we have to make 30 a fraction so that we can put these two together. Okay, we have to subtract. We need to evaluate this, see what this comes out to. So this is going to become 30 over 1 minus 12/5. And so we need a common denominator. It's going to be 5. So it's going to stay 12/5. But 30 over 1 needs to become a new fraction. Well, a different look, but same value. So 30 over 1 has to become something over 5 so that we can actually subtract these two fractions. So we have to multiply by 5, multiply by 5. That's going to give us 150. Okay? And so now we can subtract because they have the same denominator. 150 minus 12, that's going to put us at 138. 5 is prime. No other factor other than 5. 5 does not go into 138. So this expression evaluates to be 138 over 5. So notice the original expression was exact. Okay, we had fractions, no decimals going on here. So we shouldn't give an answer that's in a decimal at the end. Keep it exact. So that's number 1. Let's do another. Let's do that. Looks good. Okay, so first thing we're going to do with this expression is go to our parentheses first. So we're going to take care inside our parentheses. So we have 3/5 plus 1/2. So we have to add these together. Okay, we're going to need a common denominator. Common denominator is going to be 10. So 3/5 becomes 6/10. Plus 1/2 becomes 5/10. That's going to become 11/10. Now, there's only a 1 outside here, okay? So we don't have to multiply by anything. So this value that's in the parentheses, we just have 11/10 here, okay? We don't really need those parentheses there anymore because there's nothing else happening there. So we've performed everything that needs to be performed inside the parentheses. Okay? Plus 4 squared. Now to take care of this set of parentheses, 4 divided by 1/2 is the same as 4 times the reciprocal of 1/2, means you flip the numerator and the denominator. So 4 times 2 over 1, that's the same as 4 over 1 times 2 over 1. Remember, when you have an operation where you have one integer, one fraction, you can always make the integer a fraction by putting it over 1. So that's going to give us 8 over 1. So that's going to give us minus 8. So next is exponents, so 16. So we have 11/10 plus 16 minus 8. And so hierarchy, we're just going to go left to right because we just have adding and subtracting left. But notice we have one that's a fraction. Okay, so we are going to have a common denominator between all three if we plan on getting just to one fraction at the end. Okay, we want not to have 3 separate terms, we just want to have one term at the end here, see what this evaluates to. So we can see that 10 is going to be the common denominator here. So this is going to be 11/10 plus 16 over 1 is going to become something over 10. Okay, times it by 10. 160 over 10 minus 8 over 1 is going to become something over 10. That's going to be 80 over 10. Okay, and so 11 plus 160, that's going to put us at 171 over 10 minus z over 10. All right. And we take care of that, and that's going to put us at 91 over 10, and 91 over 10 cannot be simplified any further, so that is what our expression evaluates to be. Oh, sorry, that was number 2, not number 1. Okay, things to remember before we move on to one more problem. Remember, when you take a fraction and you raise it to a power, okay, you have to raise the numerator to that power and the denominator to that power. So 2/3 squared is the same as whatever is in the numerator squared and whatever is in the denominator squared. So 4 over 9. Okay, so we're going to evaluate number 3 is going to be, let's do 2x squared plus y squared over plus y if x equals 2, y equals -1, z equals 1/2. So if I wasn't given this piece of information right here, I would not be able to evaluate this expression because I have 3 unknown variables here, so there would be nothing for me to evaluate. But I have constant values that I want to put in for each variable, so that's the first thing I would want to do. So 2 times -2 squared plus -1 squared over 4 times 1/2 plus -1. It's important to put parentheses around what you are plugging in, what you're substituting in. So notice, -2 goes in parentheses, and the square is on the outside because you're squaring whatever x is. Sorry, I didn't mean to put a negative there. X is 2, not -2. And so we just have to make sure we follow our order of operations. So we want to take care of exponents, parentheses first, but notice there's no actual operation inside the parentheses that has to occur. So there's nothing really to do with parentheses here. So the next thing is exponents. So the only reason we have parentheses there, okay, in this case, is because we did substitution within this evaluating problem. So we're going to want to evaluate 2 squared, okay, that's going to be 2 times 4 plus -1 squared. So when you take a negative and square it, it's no longer going to be negative. -1 squared is 1. 4, okay, there's no exponents down here, notice, okay, so it's just 4 times, we still got 1/2 going on, plus -1, we can just simplify that to -1. We just have to make sure we're following our order of operations. So what we have to make sure we do is, we have to take care of the numerator, and then take care of the denominator, and then simplify the fraction. If I wrote this out horizontally, instead of seeing it as a fraction, it would look like this. Okay, so notice, you have to take care of the numerator, the denominator, and then you simplify it further. So hierarchy of the numerator, 4 times 2, that's going to give us 8. 8 plus 1 is going to give us 9. 4 times 1/2, that's going to be 4 over 1 times 1/2, that's going to be 2. 2 minus 1 gives us 1. Okay, so that is 9 over 1. 9 over 1 simplifies to just be 9. All right, so that's it for evaluating expressions. Make sure you can just take an expression and simplify it down to one term, as well as being able to plug in values and evaluate. What we'll do next is solving linear equations. So you're solving linear equations, okay, you're just going to have one variable, and that variable can only be raised to the first power. That's what makes it a linear equation and not a different type of polynomial equation. Okay, Algebra 2, we study different types of polynomial equations. We go past just the linear. So let's solve each equation. Okay, so here's our linear equation. We know it's an equation. We've got an equal sign. We know we have to solve. If we look here, what we're trying to find is the value of x that makes the left-hand side equal the right-hand side. And when we solve linear equations, what we're trying to do is get x isolated to see what its value is. So in this case, we want to undo everything that happened to x in the opposite order. So the last thing that happened to x was we added 5. So the first thing we should be doing is taking away 5. Okay, and then divide by 3, and we get x equals -1. We can always check our work, plug it back in. Okay, -3 plus 5 equals 2. 2 equals 2. When you get a true statement at the end, that's how you proved that you got the answer correct. Okay, x equals -1. Number 2. So we've got 1/2 times 8x plus 4 minus 2/3 x equals 12. So linear equation again, okay, we only have x's that are raised to the first power. And so what we need to do is gather our x's so that we can combine them when they're on the same side of the equation. So we don't know all of our terms yet because we have parentheses with times 1/2. So we want to expand and see all of our terms. So we want to distribute the 1/2. So 1/2 times 8x, that's going to give us 4x. And then 1/2 times 4 is going to give us 2. Now, we need to gather our x's. So we don't want to have more than one x term in an equation. So they're on the same side of the equation. We have what's called like terms. We have 4x and -2/3 x. So we want to put those together. So we need to put together 4x minus 2/3 x. Well, we really just want to make sure we do 4 minus 2/3, right? That's going to be what we're taking care of. So we need a common denominator. Okay, this is going to be 4 over 1 minus 2/3. So common denominator of 3. 4 over 1 would become 12 over 3. That's going to become 10/3. So when you put together, when you combine, because they're like terms, 4x and -2/3 x, you get 10/3 x plus 2 equals 12. And so now we look similar to the first problem. Okay, we only see x once in this equation. So we want to isolate x, so we're going to take away 2. That's going to give us 10/3 x equals 12 minus 2 is going to give us 10. Okay, now to get x by itself, it's being multiplied by 10/3, so we're going to want to divide by 10/3. Okay, 10/3 x divided by 10/3 will leave us with just x. So we have to take 10 and divide it by 10/3. So this is 10 divided by 10/3. Now, this is considered a complex fraction. Okay, you have a fraction within a fraction. So you can always simplify it down because this is the same as 10 times the reciprocal of 10/3 is 3/10. So this is 10 over 1 times 3/10. That's going to be 30 over 10. That's going to simplify to be 3. So 10 divided by 10/3 simplifies to be 3. So we get x equals 3. We can check our work. Okay. If we check, we get 1/2, 8 times 3 plus 4 minus 2/3 times 3 equals 12. 8 times 3, 24. 24 plus 4, 28. So 1/2 times 28 minus 2/3 times 3 needs to equal 12. What you want to get at the end is 12 equals 12. So that's going to be 14 minus 2/3 times 3 gives us 2. We get 12 equals 12. Okay? So let's do another. All right, let's do 5x plus 4 minus 2x equals 10x plus 3 minus 8x. Okay, linear equation, we have only x to the first. Okay, so we want to find the value of x that's going to make the left-hand side equal the right-hand side. So if we look here, we have x's on both sides. So why don't we first combine on each side? So 5x and negative 2x. If we combine, that's going to give us 3x plus 4. And then if we combine on the right side, we've got 10x and negative 8x. That's going to give us 2x plus 3. So we've simplified the left-hand side of the expression. We've simplified the right-hand side of the expression. Simplifying is going to be when you combine like terms. And so now what we do is we don't want x's on both sides of the equation. So we only want it on one side. So if it was to be removed from the right-hand side, if this has a value of 2x, that means we had to subtract 2x if it's not to appear on the right-hand side anymore. And so if you subtract 2x from the right-hand side, you need to make sure you do that to the left-hand side. So 3x minus 2x is going to leave you with 1x. We bring down the plus 4. So we have x plus 4 equals 3. Take away 4 on both sides. We get x equals negative 1. You can check to make sure it works. Let's move on. Oops, sorry, that was number 3. Not number 2. Number 4, let's do 5x plus 2 equals 3x plus 1/2. Let's do 4x minus 10. Okay? So we see that we're solving a linear equation because we just have x to the first. So we want to get to the point where we have x isolated. So what I see that we need to work on is we need to work on seeing all of our terms on the right-hand side as well as combining like terms on the right-hand side. And then getting x on just one side of the equation. So the first thing I do here is distribute the 1/2. So that's going to be 5x plus 2 equals 3x plus 1/2 times 4x. Okay. 4 over 1, that's going to be just 2x. 1/2 times negative 5, times negative 10. It's the same as negative 10 over 1. That's going to leave us with minus 5. Okay, now we have like terms on the right-hand side. 3x plus 2x. It's going to give us 5x. We get 5x plus 2 equals 5x minus 5. Now, I want you to stop and think about this for a second. No matter what you plug in for x, okay, 5x is always going to be the same as 5x. But then it says on the left-hand side, you're going to add 2. On the right-hand side, you're going to add negative 5. So I want you to think about this before we get our answer. Will there ever be a value for x that will ever make the left-hand side equal the right-hand side? So, let's look. We go to subtract 5x, and our x's cancel, and we're just left with 2 equals negative 5. This is a false statement, okay? This is not true. The reason we're getting 2 equals negative 5 is because no matter what you plug in for x, okay, if this is 5x plus 2 equals 5x minus 5, if you say let x equal 3, okay, this part and this part, okay, these two terms will always equal the same thing because they're exact same terms. But then you're saying you're going to if we plug in 3, it's going to be 15 plus 2 equals 15 minus 5. Because these constant terms are not the same when you have the exact same linear term here, this is, when you get the x's that cancel in a false statement, this is no solution. There is no solution to this problem, okay? There is no value that you can plug in for x that can ever make 5x plus 2 equal 5x minus 5. And let's do one more before we move on to slope and writing linear equations. So, for number 5, x plus x minus 2 equals 3x minus 2 minus x. So left-hand side, let's clean that up. 2x minus 2. Simplify the right-hand side. 2x minus 2. If you notice, the left-hand side is the exact same thing as the right-hand side. So what you should be thinking about is right now, okay, I'm trying to find a value of x that makes, to solve this equation. What that really means is that makes the left equal the right. No matter what I plug in for x right now, if I was to plug in 1, okay, I'd have 2 times 1 minus 2 equals 2 times 1 minus 2. If I was to plug in negative 10, I'd have 2 times negative 10 minus 2 equals 2 times negative 10 minus 2. Both of these would make the left equal the right. So if I go to solve this, okay, I would take away 2x from both sides. And I would be left with negative 2 equals negative 2. This is a true statement. Okay? When you go to solve and your x's cancel each other out, and you're left with a true statement, this could be negative 2 equals negative 2. It could be 0 equals 0. It could be 5 equals 5. What this means is no matter what you plug in for x, the left-hand side will always equal the right-hand side. So this is when you have all real solutions. Okay? All values are going to make this true. Whoop, drop the pen. Okay. So now let's move on to slope and writing linear equations. And then that's going to be it for part 1 of day 1. Okay, so when we talk about slope, okay, what we're talking about is the change in y over the change in x. So if I drew a line, okay, what the slope is measuring is basically the tilt of the line. How much did you increase vertically as you moved a specific amount horizontally? So that's why we do change in y over change in x, also known as rise over run. So in order to calculate the slope of a line, you need 2 points on the line. Okay, so what we'll do a few examples. Okay, so what is the slope of the line that passes through? Okay, make sure you know you need 2 points to calculate the slope of a line. Okay, we'll do a few problems. So So we're going to find the slope of the line that passes through the points 1, 4, and 2, 8. So if you notice, here's something to think about. Your first point has an x value of 1, and your second point has an x value of 2. So from the first point to the second point, okay, you've moved horizontally to the right in a positive direction, and your y's have grown, okay? So that should lead you to whether or not this is a positive slope or a negative slope. Now when we say change in y over change in x, we have a formula, okay? Change in y over change in x, okay, when you have 2 points, x1, y1, that's 1 point on the line, x2, y2, that's a second point on the line. So change in y, okay, that delta sign just means change. Change in y over change in x is just going to be y2 minus y1 over x2 minus x1. Does not matter which you call x1, y1, but you have to make sure the subscripts stay together, okay? So I'll call this x1, y1, I'll call this x2, y2. And so I just need to do y2 minus y1 over x2 minus x1. So 8 minus 4 over 2 minus 1, 4 over 1. So what that means is your y, you're going to grow vertically by 4 every 1 change in x. So that's going to be positive 4. So on the graph, okay, if you looked at the graph of this line, you should see a positive tilt forward going up to the right. Okay, second one. -1 and 8 -7. We want to figure out what the slope of this line is. So this is x1, y1. This is x2, y2. And so we just want to do y2 minus y1 over x2 minus x1. So that's going to be -7 minus -1 over 8 minus 3. So this is going to be -7 plus 1 over 5, so that's going to be -6/5. So this has a slope of -6/5, okay? And so we have a negative slope here, and what this means is y is going to move down 6 for every 5 units it moves horizontally to the right. So this slope is going to look something like this, okay? So remember, this slope, something like this, 4 would have a steeper slope than -6/5. 4 and -4 would have the same steepness, it's just one's positive and one's negative. When you say a positive slope, it means that it's y is going up as x increases. When you say you have a negative slope, that's saying that as x increases, y is going to decrease. Okay? So let's do 2 more. (8(1) and (10(1). Okay, so it's going to be 1 minus 1 over 10 minus 8. That's going to be 0 over 2. Now, when 0 is in the numerator, you are allowed to do 0 divided by 2. You have nothing divided by 2. Okay, that's going to leave you with 0. This is called a 0 slope. If I was to graph these 2 points, okay, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's the x-axis, that's the y-axis. This is a horizontal line. Okay, it's a special kind of line. It's a horizontal line. It has no slope to it, has no tilt. Okay? So the reason that we say that a horizontal line has 0 slope, look, we just calculated 0 over 2 is 0, okay, is because slope is telling us how much you're rising as you are going over a certain amount. So as I went from one x to the other, how much did I rise? 0. I didn't rise at all. I stayed the constant y value of 1. So that's why a horizontal line has 0 slope, okay? It doesn't rise at all as x moves over. Okay, so that's the third one. And the last one instead of -7, let's do -2 comma 3 and -2 comma 5. Okay? So we're going to calculate the slope that passes through these 2 points. So x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. That's going to be 5 minus 3 over -2 minus -2. So 5 minus 3, that's going to be 2. This is going to become -2 plus 2. This is going to become 2 divided by 0. So you're taking 2 and you're dividing it by, and there's actually nothing there divided by. You're saying 2 divided by something that doesn't exist. This is not allowed. 2 divided by 0, 0 is not allowed in the denominator of a fraction. This is called an undefined slope. The reason the slope is undefined is if you were to look at the graph of this line, okay? Oops. You would have a vertical line. Now remember, slope is how much did you increase in y as you went over a certain amount in x. If you notice, y is going up infinitely and it is never moving over at all. So you can't calculate the slope because you just have a vertical line that moves up and never moves over horizontally. Algebraically, how did you find that the slope of the line is undefined? You have a denominator of 0. So that's it for calculating the slope of a line. Now what we're going to go over is writing linear equations. So I erased the writing linear equations, but I'm just going to write, there are different ways to write a linear equation. Okay? One you're most familiar with probably is called slope-intercept form. And in slope-inter form, it looks like this. Y equals mx plus b, where m is the slope of the line and b is the y-intercept. Okay? You might also have seen in Algebra 1 the standard form of a line. That's ax plus by equals c. Okay? This helps you when you have your intercepts, finding your intercepts. And you also probably have seen point slope form, which is y2 minus y1 equals m times x2 minus x1, which is actually a play on your slope formula. But that's another way that you could write. But what we're going to work with when we write linear equations, we're going to work with our slope-intercept form, y equals mx plus b, because it's probably going to be the most efficient way to get through each of these problems. So we're going to work with slope-intercept form. Okay? So our directions are going to be write, comma, in slope-intercept form, the linear equation that, first one we'll do passes through, actually let's erase that, passes through, that has a slope of 5 and y-intercept of 0, 1. Okay? Now, there are an infinite number of lines that have the exact same slope. That's called parallel lines. But there is one unique line that has a slope of 5 and passes through the y-intercept of 0, 1. Okay, that's what made it unique. So, if we write it in slope-intercept form, we have y equals mx plus b. You have to show m, you have to show b. Now, things to remember. When I graph y equals 2x minus 1, okay, all of the points that make up this infinite line, all of these infinite points, okay, make this equation true. If I was to plug in 0, -1, okay, I get a true statement. This point up here is 1, 1. Okay? All of the points that fall on a line are what make the equation true. This is just a graphical representation, okay? A line is just a graphical representation of all of the coordinate points, x, y, that make this equation true. So, we need to have the slope and the y-intercept. So for this one, we can just plug it in. We know what the slope is, and we know what the y-intercept is. And it's unique. There's no other line that can have a slope of 5 and have a y-intercept of 1. So, actually we have room. Okay. We're going to write a line, okay, the linear equation, in slope-intercept form of the line that passes through these 2 points. So remember, 2 points is enough to make a unique line. So there is only one unique line that passes through these 2 points. So we have enough information to come up with the unique line. So we need to get the slope and the y-intercept. So to get the slope, okay, if we have 2 points and we don't just get told what the slope is, if you have 2 points, you know how to find the slope by doing the slope formula. So let's get m by doing y2 minus y1 over x2 minus x1. Call this x1 y1, call this x2 y2. So it's going to be 11 minus 3 over 2 minus negative 2. So that's going to be 8 over 2 plus 2. So that's going to be 8 over 4, which is going to be 2. Now, where is one piece of this slope-intercept form that is still unknown to us? And that's b. Okay, we need to find the y-intercept. Now, these 2 points fall on the line that we're writing the equation of. So these 2 points will make this equation true. So what we do is, you plug in one of these 2 points. You pick one of them. You plug it in for x, y, and the only letter still left as an unknown is b. And that will find you the correct b value. So 3 equals 2 times negative 2 plus b. So you just plugged in a point that makes this equation true because it falls on the line. So you're getting the proper b so that it actually passes through this point. It does not matter if it's negative 2, 3 or 2, 11. So that's going to be 3 equals negative 4 plus b. Add 4 to both sides and you get b equals 7. So this is y equals 2x plus 7. All right, we're going to do 2 more. Let's do so we're going to write the linear equation that is parallel to the line 2x minus 4y equals 9 and passes through 1, 1. So we have enough information to do this because, okay, here's our general form, y equals mx plus b, okay? We know from Algebra 1 about parallel. Parallel means same slope but different y-intercept. If they had the same y-intercept and the exact same slope, they would just be the same line. So we know that for the line we're trying to write the equation of, it has to be parallel to this line. It's got to be parallel to 2x minus 4y equals 9. And what does that mean if it's going to be parallel? It means it has to have the exact same slope as this line. So we just have to do a little bit of work so that we can see what the slope of this line is. So how can we get the slope of this line? We need to write it in slope-intercept form. So we want to get y by itself. So we're going to want to take away 2x from both sides. Okay. Then we're going to want to divide by negative 4. And this is y equals negative 2 divided by negative 4 is just going to be 1/2 x minus 9/4. Do we care about the y-intercept? Not really right now. We want to check at the end to make sure we don't have the exact same line. But what we care about is the slope of this line is 1/2. So if we're writing a line that needs to be parallel to this line, it has to have the exact same slope. So we know that the slope of the line we're trying to write the equation of has to be 1/2. And now we need to know what the y-intercept is. The correct y-intercept will make us pass through 1, 1 because there are an infinite number of lines that have a slope of 1/2, but there's only one unique line that passes through 1, 1. So what we do is we plug in 1, 1 for x and y so that we can find what the correct b value is that would put us through this point. So 1 equals 1/2 times 1 plus b. Okay, so if I put that over here, it's going to be 1 equals 1/2 plus b. Subtract a half from both sides. So we have 1 minus 1/2 equals b. Okay, that's going to be 1 over 1, common denominator. So 2 over 2 minus 1/2 equals b. Don't forget how to work with fractions, okay? b equals 1/2. So this equation, I'll write my final answer right here, is going to be y equals 1/2 x. So that's what makes us parallel to this. And now we want to specifically pass through that point. That must be the y-intercept so that it happens. Okay, and we'll do one more. And then that will be it for part 1. Whoops, didn't mean to erase those directions. All right. And so, the last one that we have, I believe that would be to number 4. It's going to be so we're going to be perpendicular. We want to write the equation, linear equation in slope-intercept form of the line that is perpendicular to y equals negative 3/2 x plus 4 and passes through 4, 1. Now, from Algebra 1, you know something about being perpendicular. Okay, what that means graphically is that these two lines form a 90-degree angle. Okay, and if that's happening, your slopes are what's called opposite reciprocals. Okay, so opposite reciprocal slopes would be, if you had 2 over 3, the opposite reciprocal of that would be negative 3/2. Negative 5, the opposite reciprocal of that would be positive 1/5. Reciprocal means you flip the fraction. Opposite means you change its sign. So these are examples of opposite reciprocals. So if you need to be perpendicular to this line, That means the line that we are writing the equation for, if it has to be perpendicular to this, it has to have the opposite reciprocal of this line. What is the slope of this line? Well, it's already presented in slope-intercept form, so I can already see it's -3/2. So what is the opposite reciprocal of -3/2? That would be 2/3. Okay, so that is going to make this thing perpendicular to this line, and now it's got to pass through 4,1. So we want to find the b value so that we pass through 4,1, and 4,1 would be make the equation true. So x is 4, y is 1. 1 equals, that's going to be 8/3 plus b. Subtract 8/3. We get 1 minus 8/3 equals b. So we need a common denominator so that we can put these together. 3 minus 8, that's going to be -5/3 equals b. So the equation of the line that's perpendicular to this line and passes through 4,1 is going to be y equals 2/3 x minus 5/3. Okay, and that is it for part 1.